And there we are, we have them tightened down. You can just see the goop oozing out from the edges. Everything's nice and flat. They're nice and flat thanks to their pressure from above. And there's the temperature sensing thermistor. That was bent up from the board so that it would touch the heatsink just where the the power MOSFET is. I don't think there's any point in it being where it was sensing the temperature of the PCB, because well, the PCB is not going to get as hot as what the heatsink does, so you want it on the heatsink. So bend that out from the board so it stands proud, and then let the heatsink push it back. Don't bend it straight up, you just kind of need it in a horseshoe shape, as you can see as we've got it there, so that the wires themselves kind of put some pressure on it. I suppose I could have stuck a bit of thermal compound in that area for it to sit in, but I think that'll do. I'm not expecting this to get overhot, but if I were doing another one, which I'll be doing 3 more, I think I will put some thermal compound just about there, so it has somewhere to sit in and get transfer. Right, now I'll get the multimeter out and check we've got no shorts. Okay, I've started tightening this down, and then I thought, how do I chop off that extra bit? Well, you can't, can you? I suppose I could tighten it down and aldite the thing in place with that or liquid metal, and then change the bolt for a shorter one, but I don't think I'm going to bother. I think it's just going to end up staying as it is. I'm not tightening that one yet because I had this thought that often happens, and the thought was, what's on the other side? And I thought, well, that screw is on that pad, and the only thing insulating it from that pad is the etch resist, the green coating, magic varnish. And as I'm tightening it, that insulation's probably going to fail, and then I'll be connecting that pad to the metal heatsink, and that might not be a good thing. And then I came to the other screw over here at this side for this MOSFET, and this one is going to short out 2 pads that seem to go to this capacitor, so those 2 pads are no doubt going to be not the same thing. So shortening those out, that's not going to be good either. So I'm going to have to take these bolts back out and find some substantial insulating washers, because they've got to take the stress of being tightened and under tension and not split, because if they're split, then, well, they're not doing the job, are they? They're not insulating anymore. So now I'm going to have to go find a couple of them. Well, this is the LCD that goes with this kit. I bought the kit with the LCD. You can buy it with or without, but if you buy it without, how do you know what it's doing? And it's only like an extra $5 or £3 UK or whatever for this version with the screen, so it made sense to get the screen. Fitting, easy peasy. You've got one connector on the back. It's got keyway holes in. Can you see the holes there in the sides? So you can only get the plug in the one way. There's the keyway holes on the side of there as well. So you're not gonna cock that one up, are you? It's so simple. It's child's play. Just for comparison, there's the end of the cable, and as you can see, if focus, as you can see, it's got the keys in to match the plug, so you don't have to worry about the wiring. You just shove it in and it'll work. Another thing we need to look at is this buttons panel. That's got a cutout to go over the LCD, and it just plugs on simply to this 4-pin connector at the back corner there, which has key 1, which I guess is keyboard 1. As you can see, it just goes in a straight connection. If you do put it on the opposite way, guess what? The keypad doesn't work, but there's no damage occurs. So you can put that on the wrong way, but don't worry about it, just turn it over. As said, that cable there has got key indents on the plug, so that does only go one way, and it would be most unhappy if you forced it in the opposite way. That's about it. We've got extra areas on the board there, and I can tell you that's where a pair of optocouplers are supposed to go. I guess that is so you can have a remote display. We've got this connector in the middle down here. I'm guessing that's so they can connect other panels together or do some programming and calibration and testing at the factory. I'm not sure. I bet there's some interesting signals on that connector, and I bet there's some interesting data going over that not fitted optocoupler, but that's something I'll get to in another video one day if I ever do, because I might want a remote LCD display. Then again, I might not, but if I do, I'll be having one, and I'll be finding out how to have one off there. That's about it. There's not much more to do now, except build a case for it. Okay, it's time to go for an initial power up and see where we're going. Contact. Oh, that's not looking good, is it? Why? Off. Oh, we're drawing no current. Oh, hang on, the current limit's down. There we go. It was the protection on the power supply that was tripping. There we are. I'd been testing LEDs and I'd set it to about 10 milliamps. There we are. We have contact power. It's actually drawing, according to this old meter, about 50 milliamps. So about 50 milliamps standby off the battery. Yeah, I'm not sure if that's a good or a bad thing. You know, feel free to discuss that amongst yourselves. I'd have preferred to see 5 milliamps or so off the battery, but I suppose if you're charging a few hundred amp hours of batteries, then 50 milliamps overnight's not going to hurt them. Is that 50 milliamps? I mean, I've got this set for 24 volt supply, and at that it thinks my batteries are fully charged. Let's bring the voltage down, see if we can get that to drop. Let's go down to 20. Oh yeah, there the battery's dropped. Oh, and it's the other little icon to say that the external devices can be powered has gone off, because at 20 volts you wouldn't want them to be powered. Let's take this down to 15. It's not gone off, it still says flat battery. Of course 15 volts on a 12 volt system would be quite a well charged battery. Let's just reset it by turning the power off and on again. Yeah, now it says a full battery. About 100 milliamps now of current draw, so it takes double the ampage on 12 volt as it does on 24, which kind of makes sense. It needs a minimum operating wattage or minimum power consumption to do its housekeeping, and it will be double, and it is double. Oh, there's my insulated screws with those heavy duty insulating washers. There's this deep dark conspiracy theory that they're actually being made by cutting TO22 heatsink. rubbers. I'm denying that. And I've got trumps back in to say so. Okay, we now need a battery on this, don't we? Okay, I've added a cooling fan. Not that it's going to get that hot, but I've used it to help hold the battery voltage down. Now I've got the old world power supply set to 500 milliamps. I'm going to turn it on. It's set to about 25-30 volts, and we'll see what kind of charging current we get when I power it on, because this battery will soon hit a higher state of charge. You'll see the voltage just shoots up. Here we go. And we peaked at about 800. And we're still pulling 700. On there, 500. Oh, we're back to 800. So there you are. Current multiplication by voltage reduction. That's mppt for sure. I've been playing with those pins at the back. I've been soldering wires on and LEDs on and all sorts on, and there's nothing useful on them pins that I can find. And another annoying thing with this, if I just switch this display over, come on, temperature 28.8 degrees. Let's take off the fan. Let's apply some hot air from the hot air gun and watch the temperature. I'm right on the thermistor. We've gone past 70 degrees and it's still in charge mode. And the maximum it will only ever go up to is 101.6, but we're still in charge mode. So how does that work? I'm saying that now. Haha! It has stopped pulling current. Maybe I didn't get it hot enough the time before. Let's give it a bit of fan. Might help shift some air under it and bring it down a bit quicker. I was going to say that these don't stop charging, but I guess they do stop charging, unless I've killed it. I think 50 is about the time when the fault goes off, usually. Yeah, the fault's gone. Battery 12.2, that's dropped. PV 29. I wonder if after such a fault it has to cycle. But yeah, you wouldn't want that every 2 minutes, would you? As soon as it gets warm it cuts out for the day. I don't know how cold we're going to have to get for it to start and charge again, but there's definitely no charging going on. Waft a bit of air under it. Once it gets down to 30, I'll turn the power supply off and back on again so it thinks it's been night time. See if that helps get it charging again. But that's also handy to know that if it over temperatures, it might not charge again until the next day, or until it's manually reset. And I've had it over temperature with LEDs and things on those pins, and none of the pins seem to change state. There does seem to be a data pin. There's one pin that's kind of pulsing a bit, so I don't know if we can capture that data, and maybe there's a packet in there that says it's hot. To turn the fan on. No, we've got no current drain. Let's turn the power supply off and on again. It should go off now. No, it's not. Why is it not going off? I suppose there's capacitors in my power supply that are going to have to discharge. Maybe we can use the fan. Does that help? No. Yeah, that worked. Back to battery voltage. Turn the power supply back on. And we're seeing a charge again, so yeah, I guess if it overheats, you might be stumped. Okay, after testing again the heat aspect of this charger, I'll hit it with the hair gun again. We'll put the charge back on. There's the power supply on. Without charging, it's now taking the restricted 500 milliamps, and it seems you have to get this up to about 70, and once you get this up to 70, it starts to back off the charging, as you can see. It seems you're okay up to about 90, and it will keep charging up to about 90. Just put the fan back on, get the temperature back down, and once you get back down to about 50, it says waiting for 50. Once it gets back down to about 50, it'll start to put the current back up. 52, 51.7, 50. There we are. So once the temperature drops down to 50, your charging can start again. Now I'm not sure, since it cuts the charge back at 70, I'm not sure how high you have to get it to kill the charge. And there's the charge, there's the temperature. You can watch that, I'm watching the meter. Let's try that 101 again. 101.6. No, it's not stopped the charge this time. How strange. I've gone well over this time. I hit that for Mr. Hard. But we're still dialed back on the current. So I was hoping to see it stop charging again. It seems to be a bit hit and miss about how this thing works. Definitely a bit hit and miss. That's the fan back on. We're still pulling 200 milliamps off the power supply. That's not gone back up yet. I guess the temperature's not under 50. Let me check the temp. We're about to go back up. We should see that happen now. The voltage should jump. There we go. 500 milliamps off the supply, 700 milliamps into the battery. So it is working, but it's odd the way it works, and it's so annoying that there's nowhere to connect the fan that I can find that's temperature controlled, because who wants to hear a fan going all the time? No good, that, no good. Okay, there we have a 500 milliamp current limit set on my power supply, which is cranked all the way up. Cranked all the way up to 30 volts, and it's set at 500 milliamp, and as you can see, it's not deviating from that. The power supply is holding 500 milliamps and not letting any more than that go out. Down here we have the charger working, and it's sat at 16 volts and it says charge. It's not hunting very well for mppt, but I think the fact that it's on a power supply, not on a panel, is confusing it. And it does do the mppt thing, but it stops after a while. Right, the capacitor discharge, that's on the input of the panel in. And then we'll turn the power supply back on, up to 30 volts. And as we can now see, we just had 750 milliamps going into the battery from 400 milliamps on the supply. And that'll hunt about in a minute, and it will set back to 500 because it thinks that's where the maximum power point is for that power supply. I don't know why it does that. I don't know if that's normal. I don't know anything of that nature and how it fools them, but we've got more current coming out than we have going in. 400 in, 650 out, 640 out, 630 out, and 28 volts on the panels. And just try turning the panel voltage down ever so much. How's about that? What's it going to do there? We've still got 400 in without much of a change. 530 out. It's all very odd, but functioning, doing its job. I say this isn't how you're supposed to have it set up, but well, this is how I've got it set up just to check it works. And as we've got more current out than what we have going in, we definitely have an mppt action, you know, from this mppt charger. So yeah, it's functional, it's working. Our next job is to get it banged onto some proper panels and see it do its business as it should do.